Give me exactly 60 seconds, and I am going to rescue that failing wave properties exam answer of yours from a guaranteed 0 straight to full marks. No fluff, no filler, just the exact strategies you need to survive your Cambridge Physics 0625 paper. Let's do this. Okay, listen to this answer. The wave bends because it hits the gap. If you've ever scribbled anything even slightly resembling this in a past paper, your grade boundary is actively sinking like a stone right now. This is the exact kind of painful student mistake about diffraction that examiners see literally thousands of times, and honestly, it creates instant panic when results day rolls around. You might be sitting there thinking it captures the general gist of what's happening, but to the examiner, they just see a total lack of scientific rigor.
And here is the brutal truth. Writing a vague explanation like that is going to instantly cost you 3 precious marks, 3 whole marks. On a tight Cambridge grading curve, 3 marks is easily the entire difference between an A star and an A, or even passing and failing. It's not just a tiny slip-up, it is a complete structural collapse of your answer.
Now you might be thinking, hey, I read chapter 14. I know about speed, frequency, wavelength, all that stuff. But ordinary revision completely fails you the second you walk into the exam hall. Why? Because the strict mark schemes don't test if you just memorize the textbook. They test if you can execute under serious pressure. And execution is exactly where things fall apart. This execution gap actually boils down to 3 fatal errors that just destroy grades. Fatal error number 1, missing your units. It sounds absolutely ridiculous, right? So simple, but dropping the meters per second or hertz on your wave speed or frequency calculations is a completely unforced error. You do all that brutal math, and then you just throw away the final mark because you forgot a single letter at the very end. Ouch. Fatal error number 2, rounding way too early. So let's say you're working with a wave equation. You calculate a frequency in part A, and then you need that exact number to find wavelength in part B. Premature rounding completely wrecks the accuracy of your final answer. The examiner's mark scheme is super strict. If you get a frequency of 3.33 hertz and you just round it off to 3 in the middle of your scratch pad, your final wavelength is going to drift completely outside the acceptable range. You lose the mark not because you didn't know the physics, but just because of sloppy math habits. Fatal error number 3, vague explanations. And this brings us right back to that quote from the beginning. Using everyday, conversational terms when describing wavefronts or normal lines instead of giving them exactly what the command word requires, that's going to penalize you heavily. You simply cannot say a wave bounces or bends or changes direction. It's not a tennis ball. You have to use the inflexible, precise language of physics. The examiner needs to see that you're thinking like a scientist.
So how do we actually fix this? Enter the Highmark framework. This is a 4-part system that literally guarantees a top band score by systematically building an exam-safe answer every single time. Memorize these 4 steps. Step 1, concept. Explicitly state the core physics principle. Step 2, evidence or data. Pull the exact numbers or observations right from the prompt. Step 3, scientific reasoning. Connect your concept to the evidence using a fundamental law or an equation. And step 4, examiner wording. Ditch the everyday language and swap in the strict terminology the mark scheme demands.
Now, in just a minute, I'm going to reveal the exact examiner clue that flips this whole diffraction answer completely on its head. But hold on, before we get to that, you really need to see how this framework makes that clue absolutely obvious when we look at real data. Let's put this into practice. Imagine a classic Cambridge-style practical data setup, focusing on wave speed, frequency, and wavelengths across 3 trials. Follow the numbers with me. The frequency is locked in at a rock-solid 50 Hz for every trial, but the wavelength jumps around from 2.5 up to 3.0 and then down to 2.0 meters. And look what happens to the wave speed, 125, 150, and 100 meters per second. The fundamental equation is wave speed equals frequency times wavelength. Because the frequency isn't moving, every single time the wavelength drops, the speed drops right along with it. They are perfectly locked in tandem. Okay, time to test your scientific reasoning. Pause this explainer for a second and predict which conclusion is absolutely not supported by the numbers we just saw. Think about those variables and trends. Got it? Well, if an exam question ever tries to claim that wave speed remains constant when wavelength changes, this specific data totally blows that out of the water. Because frequency is constant, speed is directly proportional to wavelength. Nailing down these trends accurately, that's exactly how you secure your evidence points in the Highmark framework.
All right, let's circle back and apply this massive rigor to our original problem. Listen very carefully to the exact examiner-approved definition of diffraction. It is the spreading out of a wave as it passes through a gap or past an obstacle, and this effect is maximized when the gap size equals the wavelength. Did you catch that wording? It is absolutely not bending. It is explicitly spreading out, and the ultimate scientific reasoning point, the one that guarantees that top mark, is stating that this effect is at its maximum when the gap perfectly matches the wavelength.
Let's whip out the examiner's red pen. On one side, we have our flawed student answer. The wave bends because it hits the gap. Big fat zero. Way too conversational. Now, look at the Highmark framework applied perfectly. Diffraction occurs as wavefronts pass through the gap with maximum spread because gap size equals wavelength. See the difference? It hits every single checkpoint. Concept, diffraction. Evidence, passing through the gap. Scientific reasoning, gap size equals wavelength. Examiner wording, wavefronts, maximum spread. That beautiful alignment is your ticket to full marks.
But here is the ultimate catch, and this is where the stakes get crazy high. You now know exactly what to write. You've got the framework down cold. But do you actually have the speed? Knowing the perfect phrase is completely useless if exam pressure makes you freeze up, overthink, and run out of time. Seriously, a flawless, beautiful answer on page 2 means absolutely nothing if page 10 is sitting there completely blank. The clock is literally your worst enemy in that exam hole. So, are you controlling the exam or is it controlling you? Don't panic, because your full exam rescue kit continues in our very next explainer. You absolutely must master the timed answer writing system next if you want to survive the clock and secure those top grades. Subscribe to our YouTube channel, Ace the Exams, at acetheexams_IGCSE to excel in your Cambridge examinations. Click over to the next explainer right now and let's beat the clock together.